Why are some volcanoes ashy and explosive, while others are runny and non-explosive? Hi everyone, I'm Kate, and in order to answer the above question, we first need to look at some very basic concepts. Come along with me. Let's first talk about what a volcano is. A volcano can be defined as opening of vents where magma from the Earth's mantle can escape onto the surface of the planet. There are two types of volcanoes we will be looking at today. The first is a shield volcano. Shield volcanoes are found at divergent plate boundaries and have less violent eruptions. These volcanoes have gentle sides and are not very steep in comparison to composite volcanoes, which is our next example. Composite volcanoes have violent eruptions and form at convergent plate boundaries where oceanic crust is being subducted beneath continental crust. These volcanoes have steep sides and alternating layers of ash and lava and are thus also known as stratovolcanoes. So, why are composite volcanoes eruptive and ashy, while shield volcanoes are non-eruptive with runny lava? The answer to this has to do with a term called viscosity. The viscosity of a fluid is a measure of its resistance to deformation at a given rate. So, the higher the viscosity, the thicker the liquid, and the greater its resistance to a flow. The lower the viscosity, the thinner the liquid, and the lower its resistance to a flow. Let's look at some basic examples of viscosity. An example of high viscosity is illustrated on the left by honey. Honey is a thicker substance and has a greater resistance to flow, and thus is flowing at a slower rate. Water, on the other hand, which is seen on the right, is a thinner liquid that flows much faster as it has little resistance to flow. Shield volcanoes are associated with non-violent eruptions and are much more quiet when erupting. This is due to low viscosity of the magma, which allows gases to easily escape. This type of volcano consists of basaltic magma of a very high temperature and has a low silica and gas content. The gentle sides of the volcano assists the lava in flowing out at a distance before it solidifies. In ashy explosive volcanoes, such as composite volcanoes, the magma viscosity is high, so there is a lot of resistance to flow. This means that there is a buildup of gases that cannot escape. Composite volcanoes have andesitic magma, which is of a low temperature. It also has a higher silica content as well as a high dissolved gas content, which makes the lava acidic, which in turn makes it more viscous. This viscosity results in an increase in pressure buildup, which results in a violent eruption. Let's look at a South African example of an active volcano site. We will be looking at Marion Island. Marion Island is South Africa's only historically active volcano. The volcano sits at a low profile of 24 kilometers wide and has dominantly basaltic and trachybasaltic magma associated with it. The island formed by two young shield volcanoes that were above a submarine platform. The island is now 1,230 meters high and has over 150 cinder cones associated with it. The first historical eruption occurred in 1980 and produced explosive activity and resulted in 5-kilometer long lava flows. Let's look at some images of Marion Island. The top image shows the island as a whole, dotted with these brown spots, which are referred to as cinder cones. The bottom image is of the Marion Island volcano that was once active. Let's go over what we learned today. We learned the definition of a volcano, the two basic types of volcanoes, shield and composite, the definition of viscosity with some examples, and how viscosity applies to volcanoes, and lastly, a South African example of an active volcano. Thank you very much.